doing, everybody? So there are going to be three things that you need for today. Remember, if you can't find it, remember you can just put pause, and you can always catch up later. But I'm going to go through this relative dating PowerPoint that was out the other day. You will need this sheet that says rock map units. You're also going to need the PowerPoint or slide presentation. It's called GeoSequence, GES, Google Slides. So I just wanted to go over this really quick since we're starting a new unit in relative dating. And what you watched the Edpuzzle video the other day, relative dating is really just figuring out how can we tell how old something is relative to each other. So we're not looking for a specific age. We're looking for this is older than this, or this one's younger, or this happened first, this happened second, or this happened last, and things like that. So we're not really going with too crazy with this vocabulary, but the underlying ideas and principles are something we should be comfortable with. So the first one is called uniformitarianism, the idea that forces that are working on our planet today have always worked in the past. So the present is the key to the past. So what does that mean? When we see beach erosion, or we see earthquakes, or we have volcanoes, all those forces that shape the landscape happened thousands, millions, and even billions of years ago. So we can interpret what happened first, what happened second, so on and so forth, because we know what processes happen today are the same things that happened in the past. And that's just the term uniformitarianism. So for relative dating, like I said earlier, we're going to determine the ages of rocks or events in relation to each other. One of the major principles is the principle of superposition, and this is pretty straightforward, that the bottom layers are the oldest, and as you go up, things get progressively younger. So even if we can do this for fossils, if we find fossils in the bottom layers, those are going to be older than the ones that we find on top, generally speaking, for our purposes. So here's just a really quick picture of some rocks. You can see the different layers. So this rock layer is the oldest. Here's the next rock layer, so on and so forth, and the youngest will be on top. Even if we find different species of organisms in each of this bottom layer here, they will be older than the ones that we find on the top. Maybe not less primitive or more primitive, but nonetheless they are older in what they are. Original horizontality, idea that sedimentary rocks and igneous rocks are deposited in parallel layers. So what does that kind of look like? And we can see this in the Grand Canyon. You see all the different stripes, which are different rock layers. The key principle is that sedimentary rocks are deposited horizontally. They're not deposited vertically. We just don't see that. If we do find them vertically, that means something happened to them. In a plate tectonic environment, they're probably moved around. Extrusions are molten rock flows that come from volcanoes. We have intrusions, so inside, when molten rock squeezes into pre-existing rock layers. These intrusions are younger than the rocks that they cross-cut. So cross-cut means that they go through. We'll see some examples of that. And here's just, this doesn't really help us, this diagram, but these are igneous intrusions that squeeze between rock layers. It's almost like if you think about a peanut butter and jelly sandwich, and you have the two pieces of bread, and you were to squeeze in the jelly in between, that would be like an igneous intrusion between those two pieces. Here's just some showing. I don't know who these people are. This is somebody else's PowerPoint. But nonetheless, here's the igneous intrusion right here. Here's another igneous intrusion cutting through that area for that. So relative dating. Another thing we need to talk about is contact metamorphism. We're not too concerned about this, but when you have an igneous intrusion, and you can see here, I'm going to figure out this in a second, that this is an igneous intrusion. And here we have something, just a bunch of rocks. This is, these each one are strata. And what we're going to do is we're going to be able to visualize and pick out what happens in what order. So for example, you can see each one of these has a different pattern. These are called map units. So if a geologist went out and actually made a map of something to visually show you what type of rock is there, they would pick a map unit and they put it in there. This is where your rock map unit sheet comes into play. So if we take a quick look at this one, if you see something that looks like a bunch of oddly shaped I don't want to say circles, but figures, and then you have a bunch of little dots. If we look at our sheet right here, we can see it's a conglomerate rock. We know it's not a metaconglomerate because these are elongated and this one isn't. Going back to this one, the next layer, a bunch of dots all over the place. So a bunch of dots right here, that's sandstone. Next layer up, we've got a bunch of bricks. If we take a look at the bricks, where are bricks? Here's some bricks. So that is the rock limestone. Next layer up, right here, we have these parallel lines. That is called shale. And then the next one on top, dot, dash, dot, dash, dot, dash, is this one, siltstone. And then the last one, how did I know this was an intrusion? How did I know this is igneous rock? If we look at our map units right here on the bottom, if you have these V's or chevrons or sprinkles or X's, the igneous rock map symbol mostly indicates it's a granite type rock. So here we have an intrusion. It comes through. It goes in between two rock layers. And what this contact metamorphism is, you see these little lines that go vertical right here. That's actually baking the rock into a metamorphic rock. I'm not really too concerned about that, but that is one way to tell the age of something. So here's an example of contact metamorphism. Faults, a crack in the bedrock where movement has occurred younger than the rocks that they cross-cut. So what does this mean? Well, you have to have a rock there to break it. So that means that the rocks were there first and then the fault. And I think we should be able to see an example of this one. So here are these rocks. This one was deposited, then that rock was deposited, then this rock was deposited, and this rock was deposited. And then it was broke by the fault. So this is what it means by cross-cut. You see this line right here? It cuts across all these other rock layers right here. So this fault happened after they're deposited. And we also know this is a fault because you can see that these lines, these rock layers should line up, and you can see they're just offset by a little, which would be the result of a fault. Oh, look at this beautiful diagram right here of all these other, especially this white line right here, this white strata, this particular rock layer right here. Of course, they all should line up. You have a bunch of faults happening right here in this area. So we know that the faults are younger because it had to break the rock to go through there. Folds, when thrusting rock layers cause pre-existing rock layers to overturn or bend. These were all used to be horizontally, but after tectonic forces, these have all been folded. So the rocks are deposited, then they are folded. You can't fold something that's not there. It's a big thing. Don't worry about this picture right here. In correlation with something we would do if we were actually in class, so there's nothing to actually be concerned about with the rest of this particular PowerPoint. So now I'm going to go ahead and cruise over and take a look at this GeoSequence GES Google Slide sheet. And I'm going to keep it in this form, kind of go back and forth between the rock unit sheet. So here we're going to do some relative dating, is the determination of the age of a rock or event in relation to other rocks or events. So really quick, here is Niagara Falls. If we were to go, if you had the pleasure of walking through our park or the Niagara Gorge or the Whirlpool trails, you would see nice horizontal rock layers in here. And this is what's basically underneath the falls. But here you have a horizontal rock layer. So here's horizontality. We have superposition too, where this is the oldest, then this one was deposited, and then this one was deposited, and then this layer was deposited, and then that layer was deposited. Geologists can go ahead and make a map showing here is what the cross-section looks like. Here's our, one term to use is a stratigraphic column. But nonetheless, we can draw all these rock layers right here. So you know on the bottom, here is shale. Next one up is sandstone. Shale, sandstone with shale beds, all the way up to the top, which is dolomite. Sometimes called dolostone. Depends on what you're going to be looking at. You might want to know what the names are for. Just a little side thing. When someone describes a rock, they usually name it for where they described it, and wherever they find that rock, it has the same name. So, for example, this right here is called the Lockport Dolostone or dolomite. And if you find it in Rochester, this particular layer, it's still called the Lockport dolomite or dolostone. So that's why they have these names right here for these particular ones that are going on. Going on to the next good thing right here. Beautiful, look at this. Grand Canyon. Nice horizontality going on. Beautiful superposition. Here's the bottom. There's something called the Vishnu Schist, all the way up to the Kayyab limestone, I think it is. I'm going to check that out in a second. But here we have millions and millions of years represented here in the Grand Canyon. And we can make a lithostratigraphic column of this one. Here again is the Vishnu Schist all the way up to the Kayyab limestone. And each of them have a diagram that goes along with it. So what we're going to do is kind of figure out what's the order of these kind of things. And we'll do a lot of practice as we go through this. So here's our first example right here. Here is a rock column right here. We are on slide 8, so we know what slide we're on. And we have a bunch of questions we have to answer. So the first one says, name each rock type. So we have dash dot dash dot. We can go up here, look on our chart. We know that is siltstone. Okay, good with that one. Next one, we got the bricks. So we can find the bricks somewhere. Okay, here's the bricks. They're not tilted bricks, they're regular bricks. So here's limestone. On top of that, a bunch of random dots all over the place. It's going to be sandstone. Excuse me. And then you have all these horizontal dashes, and that is going to be shale. So you would go ahead and name them all in here. Is there any folding? No. How do we know there's no folding? Well, number one, these are all horizontal rocks. So these rock layers are horizontal, horizontality. We don't see any wavy patterns in here. Is there a fault? No, there's no fault in here because these are all straight through. There's no breaks. They're not disjointed or anything. Are there any intrusions in here? No, because otherwise we would figure out that it would have this map unit, one of these 3 map units, in addition to another one, which I'm going to mention in a second. And then I want you to list the sequence of events from oldest to youngest. So I've done the first couple for you, so I'm going to go to the next slide. The next slide has it filled in. This is what you have to do. You would have to actually type into this PowerPoint, C is siltstone, K is limestone, S is sandstone, and B is shale. Is there any folding? Nope. Is there any faulting? No. Any intrusions? No. So what is the sequence of events from oldest to youngest? Well, we're going to stick with the whole idea of superposition, and whatever's on the bottom is the oldest, and as you work your way up to the top is the youngest. So C was first deposited, and I don't know how to do an arrow, so I use this symbol right here to show that this is what happens next. This is not a greater than or less than symbol or anything like that for our purposes. Again, it's supposed to represent an arrow to show you what happens next. So C was first deposited, then K was deposited, then S was deposited, and then B was deposited. So C was deposited, then K, then S, then B. That's superposition on the bottom, and then these are horizontal. Take a look at the next one. Again, you're going to have to name each one of these. A, you have the bricks. Again, I can go back to my map unit, find the bricks, and I'd say, okay, that is going to be limestone. Here is sandstone, and there is shale. So I've laid them, A, M, K. Is there any folding? Nope. Any faulting? Nope. Any intrusions? Nope. What's the sequence of events from oldest to youngest? Well, A was first deposited, then M was deposited, then K was deposited, and the last one I say erosion. So why erosion? Well, if you look at that, it looks like there's a little gap in between those two, and that is basically going to be a river eroding it out in an area right here. And so this is the erosion area right there. So that is the last. That is the last event to actually occur for this one. Next one. Name each rock. P is limestone. S is sandstone. Q is shale. Is there any folding? No, there's no wavies here. Is there fault? Yes, here's the fault. You can see these layers are all offset by some. Is there any intrusions? No. So the sequence of events for this particular one was P was deposited, then S was deposited, and then Q was deposited, and then the fault. So remember, these all have to be here. These rocks have to be here before you can break them. So for this particular one, the fault is the last thing to happen. Next example, labeling these, S is limestone, you have A, which is sandstone, and you have T, which is shale. Folding, oh yeah, these look like they are definitely warped. You have faulting, no faulting. Is there any intrusions? Nope. Sequence of events, S was deposited, then A was deposited on top, then T was deposited, and then they were folded. This is what's happening in this one. And the last diagram is name each rock. So Z is limestone, Q is sandstone, A is shale. This C right here, if we take a look at our map units, again, they're all over the place, all the different map units. You get the sprinkles, you get the V's or chevrons, you get the X's. These are igneous rock map symbols that mostly indicate a granite type rock. So here we have an igneous intrusion because it intrudes. You see how it cuts through all these other layers and it's an igneous rock. So what happened here? Z was deposited first, then Q was deposited, then A was deposited, and then C came through and cut through all of them. And we know it cut through all of them because not only does it go through all of them, but it actually burned all the rocks on the side on its way up. So here you have an intrusion, and once it comes out and the magma starts flowing on the outside, it becomes an extrusion. But nonetheless, that is what you're going to be doing, modeling the ones that I've done before. And I know you're going to run into some problems, and the whole point of this is kind of figure out what's going on here and what's going on. So I have a bunch of them. Remember, I will assign by slide numbers. So if you take a look at each one of these, they have a slide number on top. And so I say do slides 12 and 15 or whatever, you know what I'm talking about. I'm only going to zoom in on this one, though, really quick, and the next one. We are going to assume that these empty ones that have these vertical lines, that these empty ones are also igneous intrusions. So we're going to assume that that is granite. We're going to assume that this is granite. And there's a bunch of other examples that you're going to see as you go through them, that you have granite and so on and so forth all over the place. Again, there's just a lot of examples and practicing this skill of relatively dating which is older, which is younger, based on events. By the end of the week, we're going to go over the answers so you can check your answers, and I encourage you to go ahead and go through these and maybe go back and watch different parts of the video. That's probably the best part of the situation that we're in, is that you get to hear it all over again if you have any questions before you get really worked up. So give it your best try, and we'll go through and see how you do. So good luck. If you got any questions, please make some comments in Google Classroom in the public area. But nonetheless, make sure that you read what you're supposed to be doing for this next week. Okay, so take care, be safe, and stay 6 feet away. Talk to you later.